Hi everybody, in this video let's look at inverse variations. If I tell you y varies inversely as x, you can write this way: y varies inversely as x. That's why this is variation relation. If you want to write in equation form, we use equal sign and just add a k in front of this 1 over x. This is equation form. If you don't want to write this way, you actually can write another way, which is y equal to k over x. Let's look at the graph of an inverse function. Inverse variations. Okay, I think you still remember in Form 2 you learned about this function. This is actually a reciprocal function. If you want to draw the graph y against x for a reciprocal function, you will get the graph look like this. The graph will look like this. If the k is positive, the graph will look like this. If the k is negative, less than 0, this will be the case. But in this part, you always see this part only. Why? Because as I told before, in our daily life, we always deal with a positive number. For example, like the number of days, number of hours, and distance travel, and so on. These all numbers are always positive. The minimum can go is just 0. That's why you only see this part of graph. Okay, so this graph will become closer and closer to x-axis and y-axis, but it will never touch the y-axis and x-axis. In this case, the y-axis and x-axis are the asymptotes of this function. Okay. So how about if you draw a graph y against 1 over x? Let's say now I draw a graph y against 1 over x. Okay, now I'm just focusing on this part of graph. If you convert this graph, this part, redraw it y against 1 over x, you will actually get a graph like this, a straight line passing through the origin. Okay, y is equal to k times 1 over x. The k is a constant of variations or constant of proportionality. So this is also the gradient of the graph y against 1 over x. Okay, so now let's go back to this one. Y equal to k over x. Just now you learned about the graph. If you draw y against x, the graph will be like this. If you draw y against 1 over x, it will be like this, a straight line passing through the origin. Now, if both sides now I times x, what will happen? I multiply both sides by x. Here I will get xy. Here I will get k, right? So now you know that if y varies inversely as x, the value of x times y will be a constant. Okay, now how about we change the situation? Y varies inversely as the square of x. In this case, y varies inversely as a square of x. So we can write this way. At the square, be careful, the square of x, it will be 1 over x squared. This is variation relations. If you want to change this equation form, you just change the sign to equal, then add a k in front of this 1 over x squared. So how about if now I ask you to draw a graph? Okay, let me redraw it again over here. try to guess what is the graph that you will get if you draw a graph y against 1 over x squared. So let's say the k is positive. What's the graph that you should get? You actually get a graph, a straight line passing through the origin, and the k is the gradient of this graph. Okay, now let's go back to my note. So these are what I told you just now. Okay, now let's try some example so that you will understand better about this part. Okay, let me go back to this one. I forgot to tell you one thing. In this case, y varies inversely as x. Y is equal to kx, and when I times both sides by x, I will get this one. X, y is equal to k. So you know that the value of x times y will be equal to a constant if the y varies inversely as x. So how about in this case? Y equal to k over x squared. So now both sides, I'm going to multiply them with x squared. Here I will get x squared y. Here I will get k. So in this case, x squared y is equal to a constant if y varies inversely as the square of x. Now let's look at this example. The volume V cubic centimeters of a gas is measured at several pressures, P n over square centimeters. The table below shows some typical values of V and P. Now we have a table over here. State the change in the value of V. Okay, this is not is. If the value of P is double. Okay, now let's look at this table. Then you will see the difference between the inverse variations and the direct variation. If the value of P is double, okay, so you can look at this one, 10 to 20. If you don't want, you can look at 20 to 40. You will get the same answer. Okay, now let's focus on here, 10 to 20. Now the value of P is double. What will happen? The value of V will actually become half. If here you times 2, here you need to divide it by 2. This is the properties of inverse variation. Okay, so the value of V is half, become half. Okay, so how about this one? Part B. If the value of P is half, what will happen to the value of V? Okay, so how about I go back this way? If the value of P from 20 to 10 become half, right? So what will happen to the value of V? From 15 to 30, it becomes double. The value of V is double. Okay, so let's try the last one. If the value of P is triple, okay, from 10 to 30 times 3, triple times 3, what will happen to the value of V? It will divide it by 3. Divided by 3. Right? 30 divided by, divided by 3, you will get 10. So the value of V is multiplied by 1 over 3. Okay. Okay, let's look at this as an example. Example 14. Determine whether y varies inversely as x. So you have to be careful. If the question is asking you, determine whether y varies inversely as x. If this happens, we know that y is equal to k over x, right? So x, y will equal to a constant. So we need to find the value of xy. If the value of xy is always equal to a constant, then we can say y varies inversely as x. How about if I change this question? Determine whether y varies. Okay, determine whether y varies inversely as the square of x. So how to test? If y varies inversely at the square of x, whenever you see inversely, varies inversely, you just write 1 over. Okay, so y is equal to k over x squared. In this case, we know that x squared times y is equal to a constant. So if the question asks you, determine whether y varies inversely as the square of x, so we have to find the value of x squared times y. If it's equal to a constant, then yes. If not equal to a constant, then no. Okay, now let's focus on the blue color one. Okay, let's find the value of x times y. So this is part A. X is equal to 2, 4, 5, 8. Y is equal to 4, 2, 1.6, and 1. So now we want to find the value of x times y. If the x times y is equal to a constant, then y varies inversely as x. If it is not equal to a constant, then y does not vary inversely as x. Okay, what I said just now, I forgot. Okay, let me repeat again. If the value of x times y is equal to a constant, then yes, y varies inversely as x. This y varies inversely as x. If the value of xy is not equal to a constant, then y does not vary inversely as x. Okay, let's try. 2 times 4, you get 8. 4 times 2, you get 8. 5 times 1 was 1.6, you get 8 as well. Here, the same thing. Okay. Always the value. Okay, let me write over here. The value of x and y, the value of xy is always equal to 8. This is a constant, right? So we can make a conclusion that y varies inversely as x. Okay. So to be careful, don't write this way. This is not correct. This is y varies directly as x. So if y varies inversely as x, we need to write this way. 1 over. Okay. If you don't want to write this symbol, you can just copy this whole thing. Y varies inversely as x. If the question asks you to explain, then you just tell the teachers that the value of x, y is always equal to a constant. Therefore, y varies inversely as x. Okay, here let's try again. So this is 32. This is 32. Here also the same thing, but you have to test all. Here also the same thing, but now this become 35, right? Okay. Since the value of xy is not a constant, therefore y does not vary inversely as x. Okay, so this is a way how we determine whether y varies inversely as x or not. Okay, let's look at another example over here. Two quantity x and y varies based on the table below here. By using a suitable scale, draw the graph of y against 1 over x and show that y varies inversely as x. If y varies inversely as x, we know y is equal to k over x, right? So if you draw a graph y against 1 over x, okay, let me change this way. These two are actually the same thing. So you know that the graph y against 1 over x will be a straight line, and the k is a gradient of the graph, and this straight line will pass through the origin, right? So we need the value of 1 over x. How do we get the value of 1 over x? For y, no problem, we have all the value of y here. But how to get the 1 over x? It's actually very easy. You just need to take 1 divided by 2, 1 divided by 4, 1 divided by 5, and so on for this 10. Okay, so this is the value of 1 over x. 1 divided by 2, you get 0.5, okay, 0.5. 1 divided by 4, 0.25, right? Yes, 0.25. Okay, not enough space. I think I write over here. Okay, still can. 0.25. Okay, 1 divided by 5, 0.2. And 1 divided by 10, 0.1. Okay, let me double check again. Correct. 0.5, 0.25, 0.2. Okay, let me write clearly over here. 0.25, this one. This is 0.2, this is 0.1. So the next thing, we just need to use a suitable scale to plot this graph. If the graph that we get is a straight line passing through the origin, then we can make a conclusion that y varies inversely as x. If not a straight line, or the straight line is not passing through the origin, then y does not vary inversely as x. Okay, let's try. Okay, so now we have to focus on y and 1 over x. Just forget about the x here. Okay, when the value of 1 over x is 0.5, the value of y is equal to 5, right? Okay, so we make a cross over here. When the value of 1 over x is equal to 0.25, is the middle over here. The value of y is 2.5. Okay, somewhere around here. Let me calculate. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 over here. Okay, 0.25, 2.5. Okay, correct. So when the value of 1 over x is 0.2, the value of y is equal to 2, which is over here. Okay, let's try. Let's plot the last point. When the value of 1 over x is equal to 0.1, the value of y is equal to 1. It's over here. Okay, next thing, we just take out our ruler, connect all these points together. If we get a straight, okay, this is a straight line and passing through the origin, right? Okay, now we can make a conclusion. The graph of y against 1 over x is a straight line which passing through the origin. Therefore, so now we can make a conclusion. Y varies inversely as x. Okay, let's try another few examples. Okay, let's look at example 17. If y varies inversely as x, y varies inversely as x, 1 over x. Whenever you see varies inversely, you always start with you always write 1 over. If y varies inversely as the square of x, 1 over x squared. If y varies inversely as the cube of x, 1 over x cubed. Okay, so when we want to calculate, we always change this in equation form. Y is equal to k over x. Now, we want to find the value of y when x is equal to 4. So here I'm going to show you two methods. Let's try the first one first. Y is equal to k over x. This first method, I want to find the value of k first. I want to get an equations. Then only I use that equations to help me to get the value of y and x. I want to get the value of k, so that if I want to get the value of k, I need the value of x and y. So I can use these two values to help me to get the value of k. When x is equal to 2, y is equal to 8. So now I'm going to bring these two values inside the equation here. Y is equal to 8. K, I don't know. I want to find the value of k. X is equal to 2. So I bring the 2 over here, become multiply, k is equal to 16. Now I know that y is equal to 16 over x. Now I'm going to use these equations to help me to get the value of y and x. When, okay, let me use another color. When x is equal to 4, what is the value of y? When x is equal to 4, I just plug in 4 over here. Y is equal to 16 divided by, okay, let me copy the equation first. Y is equal to 16 over x. When x is equal to 4, y equal to 16 divided by 4, y is equal to 4. Okay, so how about, I don't want to use this method. I can use another method. It's all up to you. You want to use this method or the method that I'm going to show you here. If y varies inversely as x, y is equal to k over x. I know that x times y will be equal to a constant. If I understand this concept, I can use this one to help me to get the value of y. Okay, x times y is always equal to a constant, right? So x times y, x times y. Okay, let me write this way. When x is equal to 4, x is equal to 4, I know x. Y, I don't know. I just write as y. This is x times y. We know that x times y will be always equal to a constant. It means that this x times this y will equal to this x times this y, right? 2 times 8. So y is equal to 16. This 4y is equal to 16. So y is equal to 16 divided by 4. You get exactly the same answer. So if you want to try it on your own, you can try both methods. So it's all up to you. You want to use this method or this method. Okay, for part B, I will use this equation to help me to get the x. If you want to try this method, you can try and see. You should be able to get exactly the same answer. Okay, now let's go to part B. Let me write the equation first. Y equal to 16 over x. When y is equal to 10. Now I'm going to plug in the 10 over here. Oh, 16 over x. 16 over x. So 10x is equal to 16, right? So x is equal to 16 over 10. Actually, in the exam, you don't have to write this step. You can just interchange their places. X go up, 10 go down. You will get from here. You can directly go to this step. So x is equal to 1.6. Okay, so this is the way how we solve the question for an inverse variations. Okay, let's try one more example. A fixed quantity of gold is melted and cast into a number of cubes. The number of gold cubes obtained varies inversely. Okay, so we have to look carefully this sentence. The number of gold cubes obtained varies inversely as the cube of the length of the edge of each gold cube. It look quite confusing, right? Okay, so I just let the number of gold cube be n, and the length of the edge of each cube is of each gold cube. It means that if I okay, let me draw a cube for you. Okay, so this is a cube. All the sides same length, right? Because this is a cube. So I just let the length of the edge of each gold cube be L. Okay. Let me go back to this sentence. The number of gold cube varies inversely. Still remember what I told you just now? When you see varies inversely, 1 over. As the cube of this. Okay, this is variation relation. Okay, this is cube. This is variation relation. But when you want to calculate, we always write it in equation form. N is equal to K over L cube. We put a cube here is because as the question tells us varies inversely as the cube of the length of the edge of each gold cube. Okay, so make sure this one you write correctly, otherwise you will get the wrong answer. Okay, the edge of each gold cube is 2 centimeters long. It means that the L is equal to 2 centimeters. When the fixed quantities of gold is melted and cast into 27 identical gold cubes, N is equal to 27. Okay. So I am going to get the value of K first. When N is equal to 27, L is equal to 2. So what is actually the question asking is, the question asks you, when 8 identical gold cubes are obtained, it means that when the N is equal to 8, calculate the length of the edge of each gold cube. What's the value of L? So it's okay, now we just forget about this part first. We find the value of K first. Once we have the value of K, we have an equation, then it's very easy for us to get the value of L when the value of N is equal to 8. Okay, when N is equal to 27, I'm going to bring the 27 over here. K, I don't know, I want to find the K. L is equal to 2, but don't forget to put a cube here. Okay, so 27 is equal to K over 8. K is equal to 27 times 8. Partially. Okay, 216. Now I know that, let's go back to this equation. N is equal to 216 over the cube of L. Now I am going to use this equation to help me to get the value of L when the N is equal to 8. When N is equal to 8. 216 over L cube. So you have to be careful, remember to write the cube over here. So I'm going to interchange their places. L cube go up, 8 go down. Okay, L cube is equal to, you just press the calculator, 216 over 8. Sorry, this is L cube, not L square. Okay, L cube is equal to 27, so L is equal to cube root of 27. Now we know that the value of L is actually equal to 3 centimeters when the value of N is equal to 8. Okay, so that's all for this inverse variations. Hopefully you understand better after watching this video. Thanks for watching and see you next time. Bye bye.